Hello, I'm Hardy Wenzel, and I've been asked to speak to you today about solving the sustainability puzzle through the lens of the complex wood supply chains. Trees have always been with us, offering comfort, protection, and oxygen. They clean the air, filter our water, keep us warm, and provide us shelter, and they are our future. Why am I talking to you today? Well, I have 4 decades in the industry and know what it takes to develop engineered wood products. I started at the beginning of the engineered wood products revolution, working on the creation of I-joists, LVL, Paralam, OSB, and more. And I saw firsthand how quickly engineered wood products become the standard. In my time in business, I've also seen how nature and man can affect our forests and how they recover. Acid rain, the eruption of Mount St. Helens, Chernobyl, the spotted oil crisis in Oregon, the Clayoquot Sound, old growth forest, First Nations dispute on Vancouver Island, and today, climate change. Because of that, I can say the future has never looked better for wood, and it takes 40 years in the business to know it. Wood is the oldest building material we know. The Bailey Homestead log cabin in Indiana, built in 1860, could possibly be the original mass timber building technique. Left of this log cabin, you have the Toji Pagoda, built in 1650 of the current era. In the top right, you've got Faroe Island in Denmark, built 100 years in the current era. And then the bottom, you've got the Namib Desert in Namibia, where there are no trees present whatsoever in this desert, yet people are building with wood. It may be our past, but wood is also our future. There's intelligence in wood. In building with wood, I say that because wood is renewable and our forests in North America today are managed well. Wood is good for the climate because it sequesters carbon. Wood is strong and can now be engineered to solve complex building challenges. It offers smart design and living choices. But yet there's a growing need to verify the wood we use is from forests that are sustainably managed. The challenge is tracking the chain of custody with confidence. We all want to make sure the wood we're using is responsibly grown, harvested, replanted, and good for the environment. But the process of converting trees into wood products is complex. It can be hard to track the chain of custody for each stick of lumber because of that complexity. Because even in a single forest region, you can have trees that are certified and uncertified. And those trees can go to multiple mills. Then, after trees are turned into lumber, some of the wood travels to several mass timber manufacturers, who in turn put it into an even greater number of buildings. Parallel to making mass timber, most of the lumber shows up at home centers and lumber yards across North America that service both builders and DIY users for projects on their own. In fact, sourcing sustainable lumber is much like sourcing sustainable energy. To show how complex the process is, we'll start at the source. The beauty of finding wood is that it's all over. There are more than 1 billion acres of forests in North America. Over half of that land is certified as sustainably managed, backed by FSC, SFI, CSA, and American Tree Farm certification, as well as state and provincial laws. Now that's 5 times the area or the landmass of the state of California. And the land that isn't certified may be owned by companies whose businesses depend on maintaining healthy, productive forests. It's their business. And you can see here how large that business is. It's in their interest to keep these forests thriving. Plus, there are layers of legal regulations and obligations to abide by. And you'll also notice here that the top 5 lumber producers account for only 35% of the lumber market share. That begins to create a very fragmented market, and that fragmentation is another factor that makes it even more difficult to track chain of custody of lumber. While we're talking about fragmentation, I also want to take a moment to show how logs are converted into lumber used for mass timber and how that further affects chain of custody. The process itself is standardized, so a 2x6 of a certain grade in one mill is the same on the other side of the country. But it's rare that a log is one homogeneous grade of wood. Grade varies within the log itself. So not only are a number of sizes cut out of a given log, different quality grades are cut out of it as well. That means just because a tree is from a certified forest, it doesn't ensure a piece of lumber meets the technical requirements for mass timber. Ultimately, the primary goal is maximized utilization of each log harvested. Now, going back to the forest, this map illustrates the variety of softwood species in the US. There are a lot, and because all of the different natural resources these wood baskets yield, it's another factor in creating a diffuse supply chain. The first thing in how logs become lumber is harvesting. Once harvested, the logs are sorted for their best economic use in the forest. Then they're transported to the appropriate mill's log yard. Logs often come from different locations and multiple landowners from both certified and non-certified forests and are mixed together, again adding to the challenge of maintaining the chain. Cut logs are further sorted by the ROI to the log to determine their best use as a finished product. This can be lumber, plywood, oriented strand board, even pulp for paper. In the mill, logs are turned into those finished products, and little is wasted. Dust, chips, bark, almost everything is used. Finished lumber products then enter the building materials supply chain and are traded as a commodity. And in a commodity, whoever pays the most gets the wood, and this further dilutes the chain of custody. In many cases, when lumber reaches the lumberyard, it's mixed with other products that have been purchased, all coming from different forests. At that point, they're unbundled and offered for resale. As you can see, at that stage, the chain of custody is even less precise as more dilution occurs. For creating mass timber, these materials arrive from multiple mills in various locations to meet demand. We then use these different machine centers to create mass timber products following a number of detailed steps as you see here on the slide. We have to condition the lumber, it gets finger jointed and planed, it gets then sorted and organized so that we have the correct layup per the manufacturing standards and the engineering specifications. Gluing and pressing happens, and then it gets fabricated by a CNC machine to create a kit of parts. Finishing occurs, and then it gets packaged and shipped to a job site. A single mass timber component can contain dozens of pieces of lumber, each from a different forest, making that chain of custody even more difficult to track. Not to mention, one project can contain hundreds of components, creating the kit of parts for a building. As I said earlier, just because a piece of wood comes from a certified forest doesn't mean it can be used in a mass timber project. That's because before a piece of lumber can be incorporated into a piece of CLT panel or a glulam column or beam, it has to meet a set of very specific and stringent manufacturing and structural requirements to ensure its performance. That means you can only use a small subset of that material that comes out of the forest, making the chain verification even more challenging by reducing the pool of available resources. It's all about the outcome. There's a lot of discussion about whether you should source lumber from SFI or FSC certified forests. And the short answer, in my opinion, is that it's all good. These are lands that are monitored for best use practices and sustainability. In fact, even if it's not a certified forest in North America, it still can be sustainably managed. Maintaining healthy forests is always in the best interest of the landowner and the industry. In most jurisdictions, there are laws in place to ensure that we don't harm the environment, we don't hurt the dirt or the people who work there. Additionally, forest management is better than ever. There's a focus on sustainability, better harvesting methods, better reforestation methods, and overall health. I can't think of a better representation of forestry management than Mount St. Helens eruption that happened in 1980. With excellent management and reforestation plans, it's again a thriving forest, decades ahead of initial projections. And you can see on the image on the left side of the slide where forestry management has occurred and where natural reforestation has occurred. And you can see a very distinct difference in the vitality of the forest. One more final thought: proximity matters. North American mass timber producers understand this. That's why you'll find a number of manufacturers in the Pacific Northwest, North American Northeast, and the US South close to the forests. This results in a smaller carbon footprint. And without oceans to cross, transporting products is simpler, faster, and less expensive. It also puts the benefit of responsible forestry in our own backyard rather than on another continent. In fact, when considering mass timber from European suppliers, one needs to compare transportation emissions. The chart here compares the emissions to serve a project in Milwaukee, Wisconsin, from the wood baskets of the Pacific Northwest, the North American Northeast, and the US South against an Austrian supply. And in the table, you can see indexed to the Pacific Northwest and British Columbia, the carbon emissions that happen from these different supply sources. It's a very compelling story. I know you're a group who is likely interested in supporting and driving forest practices that push the envelope when it comes to climate smartness. Even though the process is complex, you can help to drive change. A possible approach could be pushing for a system of purchasing carbon credits from the forest that's equal to the quantity of the wood you're using, or perhaps of finding ways to document that the wood from the sources you want to support is entering the primary supply chain of a mass timber manufacturer, even if it's not tracked afterwards. Or maybe it's something else entirely new. But remember, we all have the strength. If the demand from consumers and the market is strong enough, the business will follow. If there's one thing you should leave with today, it's the idea that wood is good no matter where it comes from in North America. And even if you can't track its chain back to a single log, remember, all wood sequesters carbon. What you can build with it is growing constantly, and people want it. And most of all, it's smart for both the planet and for business. At the end of the day, the alternative to building with wood is to continue to build with concrete and steel. But we know this is not the solution we're all seeking. Can we continue to improve as we move through our journey? Yes. Are we standing still? Not at all. Continuous improvement in forestry and wood science is happening every day. My 4 decades in the industry can attest to this. I am not a forester, but I am a mass timber enthusiast because mass timber is a key ingredient to solving climate smart construction, one that creates sustainable places for people to live, work, and play. Thank you for listening.